Nowadays, as clinicians and academicians or academics, cannot say academicians, ugh, we try to tell everybody, patients, just anyone out there in the real world, that if you're going to be out and about, you need to pay attention to what you're exposing yourself to, especially if you're going to be out, parks, um, out in the forest, even some of the nature reserves you'll see, like Forest Park, things like that. You need to pay attention to what's, creepy crawlies are getting on you. One of them that we now are paying more attention to, because we're starting to see that it has long, chronic implications, is Lyme disease. Lyme disease is a slow, progressive set of symptoms. Now, when you get a set of symptoms, sometimes a lot of times you'll see this referred to as a syndrome. Okay, if it's a syndrome, there's a long list of potential symptoms and signs, and your patient's going to have, certain ones. Doesn't have to have all of them, but there's a few key ones, and then there's a few that come along with it, and it's going to be slightly different patient to patient. With Lyme disease, the two symptoms or two sets of symptoms we see most often, which is one of the cues that it's a Lyme disease, is neuromuscular issues, and the patients will begin developing what appears to be rheumatoid arthritis, but when you run the tests, the serology test and whatnot, for the markers of rheumatoid arthritis, they're going to come up negative. They're also going to have what is, at the time of the bite, at the beginning, before any of these other signs and symptoms appear, there's going to be this initial symptom, erythema migrans. Okay, this will be at the site of the tick bite. The tick's going to go in, it's going to bury its head through the epidermis into the dermis, because they don't have a proboscis like a mosquito does, so they burrow in, and they start their blood meal. What's going to happen with this erythema migrans is the area around the tick bite is going to get inflamed. And it's not going to be one big red area, kind of like, a larger version of mosquito bite. No, this is going to form a ring. They call that the bullseye. What's happening here is, as the inflammation kicks in, as the protein markers from the tick bite start to spread through the tissues, the immune response is going to create that bullseye appearance. Now, here's the problem. That bullseye doesn't happen in everybody, about 10% of the cases. So if somebody shows up, in your clinic, in your ER, and they're complaining, they got this bug bite, it hurts, it's bothering them, and you look and you see a ring, and it will be a well-defined ring. Ding, 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 tick bite. You need to start looking at the probability of they may have been exposed to Lyme disease. So when you look here, you see the picture. It's not a perfect circular, but there will be a reddish raised at the site of the bite, and then a space, and then that ring. Okay, like I said, a lot of this is going to be due to the inflammatory response due to the presence of the bacteria. You look at the smaller circle, you'll see that the ring remains for a while at the site of the initial bite, that may actually clear up. Other symptoms that will start to appear These aren't fast. These are going to be appearing a day or two, maybe even a few days later. Fever, headache, stiff neck, dizziness. Okay, this is the inflammatory response, an all over body inflammatory response. We're trying to get across to people that if you get a tick bite, you start to see the development of the bullseye, the erythema migrans, you need to seek medical attention. Because if you seek medical attention early enough, minimize the chances of the chronic issues. But if you don't get it treated, or you wait too long, wait until the fever, the headache, the stiff neck, dizziness, oh, by the way, I got this tick bite a couple of weeks ago, well, then you start to have issues, cardiac, neurological symptoms. The facial palsy is going to be due to the autoimmune response that may occur with Lyme disease. Your own immune system starts attacking the vagus nerve. Palsy is going to be misfiring of the nerves that innervate the face. The muscles of the face will not function correctly and you'll start to droop. If it progresses long enough, you're going to get the crippling arthritis. The neurological complications can be anything from mental issues, inability to, coherent thought, higher brain function, may a little bit impaired, memory issues, memory recall, laying down new memories, short-term memory issues will be a problem, neuromuscular issues. Causative agent of this is a bacteria known as Borrelia burgdorferi. Okay, it's a spirochete. Okay, remember the spirochetes are the ones that look like corkscrews. The problem here that we find with Borrelia is that it can mask its appearance. It can, once it's in the body, remember it's a bacteria, so one bacteria, binary fission, 1 becomes 2, 2 becomes 4. Well, after so many rounds of those divisions, those resulting cells, while still a spirochete, the surface proteins, the surface markers on that 3rd, 4th, 5th generation looks absolutely nothing like the original bacteria that was spit into the patient's body by the tick. Have to keep in mind, your immune system does not recognize Borrelia. Your immune system does not recognize the influenza virus. What your immune system recognizes is a part, an amino acid sequence as part of the spike on the surface of the influenza virus. Your immune system doesn't recognize the entire bacteria. What it recognizes is a specific amino acid sequence or a specific sugar sequence that's part of a glycoprotein on the surface of Borrelia. So all Borrelia has to do is alter that sequence just a little bit, change 1 or 2 amino acids, switch around the orientation of one of the sugars, and it's now something new, and your immune system is going to take 2 weeks, up to 2 weeks, to relearn it. In this mimic process, in this evasion process, some of the amino acid sequences, some of the sugar sequences, and the glycoproteins can somewhat resemble our own. Things that would be found in a mammal, things that would be found in you. So while your B cells and your T cells, those that would respond to self are generally killed, well, there's enough of an overlap for the B cells to start making antibodies that might cross-react with proteins on the surface of our own cells. So we start to see this autoimmune response. Rheumatoid arthritis, people who actually get rheumatoid arthritis start making antibodies to proteins in the joints, the synovial joints of, their wrist, their fingers, their arm, their elbows, their knees. So they start to mount an immune response and start damaging and rearranging those joints. See the same thing here with Lyme disease. Start to make antibodies, start to mount an immune response against self. And there's the danger. Once we start to make antibodies and an elicit immune response to self, you can't turn that off. So this is one that's going to be spread, by ticks, kind of like with the Francisella, the, rabbit fever. This is a tick-borne, specific tick in the genus Ixodes, and specifically Ixodes scapularis. Okay, not all ticks throughout North America can harbor Borrelia. Not all ticks around the world can do this, so this is going to be within certain areas. Scapularis in certain areas, Pacificus, California in areas. So it's going to be different ticks, different areas, but it's going to be roughly the same type of a life cycle. Turns out Borrelia is either in ticks or it's in a mammal. Okay, it's the only way it works. We're a dead end. Okay, rarely, if ever, is one tick going to bite us and then another tick's going to come along a little while later to get a blood meal and pick up Borrelia and then pass it on to another person. That's why you see here that we humans branch off. The quote-unquote normal life cycle is here. Larval ticks will slowly develop. We'll go feed off of deer, rabbits, whatever, larger mammals, lay eggs, hatch, the larvae and whatnot are going to go, start feeding on mice. They're going to give the mouse Borrelia. Different generation or different stages of ticks are going to feed off the mice. As they get bigger and older, they're going to then progress to larger mammals. Larger mammals going to get eaten. Eggs are going to get laid. Eggs hatch. Blah blah blah. And just it's this cycle. Large mammal, small mammal. Large mammal, small mammal. But us humans, we're always off as a dead end because either we die or we get treated and Borrelia gets killed within us. Third option is once we get sick, we stay the hell away from the forest, so we stay the hell away from ticks. So when you go and you look at Lyme disease, okay, just because you see the areas up here, northeast, upper Midwest, and along the coast here, just because these are the predominant areas doesn't mean you can't get it in other places. What this map doesn't show is there are cases throughout the Midwest here. There are cases through Texas, up through here, Pacifica. So Lyme disease, there are areas where it's not going to be. You don't see it up through, here, the Rockies. Turns out Rockies have their own diseases because of different ticks and whatnot there. But you have to keep in mind, people travel. People travel. People go someplace. People come back. So they may go up, to New York City. Maybe go do a little hiking out while they're out that way. Get exposed, come back to St. Louis within a few days, and then a week or so later, they're going to start showing symptoms. Remember, they're not always going to have that red bullseye, so it may be a few months later they start to show symptoms, a year later, and they're starting to show advanced symptoms. Unfortunately, ticks get in on stuff, packaging, stuff like that, gets shipped all over the US. You go, you find something gets around in your house, next thing you know, you get bit. So that's why, even though here, St. Louis area, there's not much or any in the way of Lyme disease, but you still have to be aware of it because people and things travel. When it comes to diagnosis culture, it's really not very useful. Okay, there's very few spirochetes out there that are going to be human issue, that are going to be in the blood. So it's going to be initially early stage history. Where have you been traveling? What have you been exposed to? Did you ever have a tick bite? Were you ever bit? Later stages, they have ELISA or Western blots. You can take serum samples and test for either the presence of the bacteria, or you can test for the presence of antibodies to the bacteria. If somebody has antibodies to Borrelia, then that means they've been exposed. And if they're showing symptoms that are, in the list for the syndrome of Lyme disease, then you start treating as such. Prevention is going to be tell everybody wear insect repellent. If you're going to be out in the field, you're going to be out traipsing in the woods, spray a little on, okay? Spray it on your clothes. If somebody's been out and about, even with, spraying on some DEET doesn't last forever, do a quick body check, okay? Look for any weird looking spots, freckles, moles that shouldn't be there or weren't there. Look for a freckle that seems to be moving, okay? That's a tick. When you go to remove the tick, you either want to use forceps or they have special little tick removers. You do not want to grab it and just crush. You don't want to grab it and just rip, because you grab and you rip, you can leave the head in. The head will then start to decay, and next thing you know, you have a small little, infected wound. If you catch early enough, doxycycline and amoxicillin is effective against Borrelia burgdorferi. If it's later stages, they've had it for a while and they're now showing later stage issues, there's a pretty good chance Borrelia may not even be there anymore, and now treatment's going to be more supportive, trying to minimize the autoimmune issues.